Okay, good afternoon, everybody. You've got me again. So, my name's Pete Ramsay, and the topic of my presentation, this is not going to be too long, is artificial intelligence, a force multiplier for side-scan sonar reporting. My name's Pete Ramsay. I'm Director of Strategic Hydrographic Programs at Klein Marine Systems. Right, so why do we think that it's actually necessary to bring artificial intelligence into our survey industry for data analysis? Well, if we have a look at it, in the modern commercial and military survey applications, we're finding that the volume of data that's acquired in every single mission is growing rapidly. We're also finding that surveys are happening with swarm-type vessels, so you might be out there with 3 or 4 different uncrewed vessels, and you're collecting the data, and you are collecting literally terabytes of data a day. How does the human actually analyze that? So we've been working on tools to improve the human sonar interface. So an example, I was having a chat to some customers of ours who've bought into our artificial intelligence software. And they were saying that previously in their wind farm jobs, a single geophysicist would digitize 10,000 boulders. I don't know if any of you guys would like to digitize 10,000 boulders, and that was on every single job. And that is a soul-destroying thing. I said to him, digitize 200 boulders, put it into artificial intelligence, and never digitize a boulder again. So, so if you're having a look at data like that, if you just had to take this small little area over here, and you had to digitize every single boulder in that image, it's going to take you a fair amount of time to do that. So how did we approach this? So we used a deep learning model for ATR, stands for automatic target recognition. We started doing this about 3.5 years ago, and we designed new cutting-edge software which actually does interface into HiPAC. We're busy working with HiPAC at the moment to take the products into the target editor. So what it does is it uses a convolutional neural network for automatic target detection. And we actually train the CNN using sonar targets of interest in the context of their background. So let's say you've collected a whole lot of historical targets and you'd actually digitize them in Sonar Pro. We're able to take all those historical targets from projects you've done years and years ago and pull them into the artificial intelligence as well. And the real difference between our system and any of the other systems is that we use raw 32-bit sonar data. We don't use pictures, we don't use imagery. So a lot of the other non-sonar manufacturers who are doing artificial intelligence and sonar are using essentially a photograph of a target to train their CNN. Once you've generated a photograph, you've lost more than half the information in that sonar data. So we go back to the raw imagery, pre-TVG, pre-everything, and that's what we work with. Because we're the sonar manufacturer, we actually understand the raw data really well too, which is another advantage. So basically with ATR, the philosophy, automatic target recognition, is that you take a data set, and let's say you're working with client data, SDF data format, and you're going to annotate it. Now, annotated means that you are actually going to digitize targets in that data. And you saw Daniel digitize targets, and you've seen Karen do targets. We do it exactly the same way, we just do it in our software. And you'll categorize those targets. So let's say you find 5 different classes of targets in your survey. Some are tires, some are mine-like objects, let's say some are pipeline segments. So you're going to digitize all of those and classify them. You're then going to decide on what you want to train your model on. Let's say you're only interested in finding tires or human bodies or something like that. So you are going to train a model based on the targets that you've collected. And in our experience, we found that about 200 is about the right number. We have gone as low as 20 targets, but I'll explain that to you a little bit later. There's a way to do that. Once we've defined what model we want, we train it, we build the model, we then run automated target recognition, and we can feed those results back into our data, into our model. It's a process called active learning. So let's say, for example, that I only have ever seen 20 of these targets. So I'm going to create a model based on 20 of those targets. It's not going to be a very robust model, but the next time I collect data, in that data set there might be another 20 targets. So we let the ATR find those extra 20 targets, build it into the model. I now have a model based on 40 samples. And as you go further and further along, you can actually refine and build your model. So based on that philosophy, we developed a couple of different software packages. And the one is called Scribe Pro, which just does the review and annotation of side scan data. We developed another package called Nexus, which does the training and the modeling, based on the targets that you've selected. And we've got another module called Scribe ATR, which is the automatic target recognition processing. And just to simplify things, we just added this into that, and it's just an extra toolbar. So essentially, you have two utilities to do all of this at the end of the day, which is great. So what I'm going to do is not bore you to death with PowerPoint. Let's actually go and load up. So this is the software package here. So this is Scribe and ATR. So what I'm going to do is I'm going to create a project from scratch, show you how to do it. So I'm going to create a project, and we're going to put it in the HiPack folder. Any idea? What are we going to call it? Ralph, what do you want to call it? BS. Okay, there we go. It's a BS project. Okay, so in this BS project, we're going to pull in some data. So now we're going to add some data. And what I'm going to do is I'm going to add some of the files that Daniel showed you from our UHR system. So I'm going to add a bunch of files. Now, this is a lot of data that I'm actually adding. And you'll see how quickly it actually does it. So it's indexing the files now. And it has already loaded all of those files in here. So we can have a look at the metadata. And we find that our mission time was just under 4 hours. That's including turns. And about, call it 2 hours of data acquisition. So we've got 2 hours of data, and that loaded very quickly. We have a bunch of windows over here. We've got a map window, and you can see our vessel, and you can see those are the survey lines over there. So what we can do is we can load in a background chart. So what I'm going to do here is load in a background chart. And we've got full access to the Esri library. So I'm going to just load in a background chart, and you can see where this is now, just off Panama City Beach. So there it is. And we can load in any multibeam data, anything like that that you want. So I'm going to import just any ASCII objects. So these are ASCII targets, which I'm going to find now. So it's a list of ASCII targets. And that's exactly what the file says. So it's target, lat, long, etc., and the name. So I'm going to give this a quick name here, targets. And I'm going to call it labeled points. Labeled points. I'm going to skip the first line because that's just the names of the columns. And the first one is name and lat long. And it fills in, it automatically fills in what the DD format is of your lat long. And it's now imported it. So as I zoom in over here, I can see, what my target names are actually there. Right, so let's have a look at the data. So I'm just going to make that a little bit smaller here so we can see our data nicely. So I'm just going to start replaying some of the data. This is the data which that Daniel showed you a little bit earlier on, and I can increase the speed of it. So I'm playing it. What I also like to do is I like to do speed correction on my data. So I'm actually speed correcting the data now so that any object is not distorted. It's completely isometric. So I'm busy reviewing it and I say, oh, that's not particularly interesting bit of seafloor. But the nice thing is that I've got a nice dynamic library here, and I can go skip to any part in this data that I want to. So while I'm reviewing that, I can go, I'm not too interested in that. I want to sync my waterfall position to start looking at that line. So now I'm starting to look at another line because I see there's some interesting targets here I want to look at. So I'm going to speed up the data, and I'm going to look at that target. So as I'm going along, wow, I found a target. So now I can start zooming in. And here we are using the native resolution of the sonar. So this is a very high resolution sonar. So if I start showing you, this is a high resolution sonar. So again, you can zoom in and zoom in and zoom in. And what this is as well is this is like an iMovie profile. So there are all my lines all compressed. So in my little window here, I can tell I'm exactly there. These are the breaks for each of my lines, so I can see where I am in my survey. And as I'm reviewing a line, it actually tells me that on that first line, operator Pete has reviewed 25% of that line so far. So it's keeping an audit on what I'm looking at as well, which is really important. So again, one of the things that I'm going to do is I'm going to just do, a couple of targets. So I'm just going to target this particular object over here. So it's created a target, and I want to, let me make this a little bit smaller. Bear with me a second. Yeah, there we go. So I want to just zoom in a little bit on that target. I'm going to just, crop in there a little bit more. I just want to collect the shadow and the actual target. That's important for automatic target recognition. So I'm going to just crop that. So now it's zoomed in a little bit. And the neat thing is that because this is a dual frequency system, I can look at the high or the low frequency. So that is the high frequency. I'm going to show you the low frequency. But as I digitize a target, I can look at the low frequency versus high frequency target data. It's called a swipe tool. You see on this side is the low frequency, and the other side is the high frequency, and I can swipe it in this direction too. So now let's say that you had something that was partly buried. You can see whether you can actually see it in the low frequency compared to the high frequency. It's called a swipe tool. Pretty cool. As I generate a target, it'll automatically measure the width and length of that target. See? It's automatically measured at width and length of that target. Now I can classify this target. And this is a target classification I built up out of every single database on the planet, literally, about what people call things. So this is called a MILCO, which is a mine-like contact. It's what the Navy would call it. So that's classified as a MILCO. So I'm looking at that, and I can actually tell the probability. I know that that's a MILCO. I'm 100% sure because I'm a sonar expert, so I'm going to say I'm a 100% probability. So now I'm going through this data, and I'm going to go through a little bit more, and I'm going to see if there are any other targets of interest. Let's see if we find anything. Right, there's another object over there, and let's just have a look at this. The other thing that I can do as well that's pretty cool, now there's another mine. This is a triangular shaped mine. So I can also just do this little window here, which we call a peak window. So I can just do that. And now I'm automatically looking at the low frequency. See, that says the high frequency, and this is the low frequency data. So I'm just having a peek at the different data sets. So I'm able to do that in this window. So I can go zoom along, and I can actually look at, there's another interesting object. So I'm now going to zoom in, and I'm going to have a look at the high frequency data there. So I'll just go and peek at the high frequency data, see the difference. It's pretty cool the way this works. So let's say I'm not going to bother digitizing. You can see how I can go in and I can digitize and classify all my targets. Now, you look at my audit trail. I have looked at 3 lines, and I haven't done a particularly good job so far, but now I'm going to use ATR. So what I'm trying to find in this particular area is I'm only really interested in, I'm not interested in these little lines over here. This is my area of interest. So I only want to apply automatic target recognition in this particular area. So I'm going to create something called a geofence. And just let me select this properly. Come on. Right, so I'm going to, just bear with me a second. This mouse is not working 100%. Right, so I've now created, has it created a geofence? No, I don't know why my mouse is not working 100% on this. I apologize for that. Let me make this a little bit bigger so that it works. It's when you project things at different resolutions that this is the issue. There we go. So I want to draw a rectangle around this. So that's my area of interest. So that's what we call a geofence. The automatic target recognition will not look at anything that is outside that. So I'm going to say I'm only interested in stuff that's inside that. So it's created a geofence around my data. So now just let me make that a little bit bigger. Okay. Now I'm going to load a model. Now this is an area, this is a minefield. So I'm going to load a model. And the model I'm interested in loading, this is a model I've created a while ago based on trained data. And this is a model which actually finds mine-like contacts and tires. You can create a model to find anything, and the more categories you have, the better. So you can create a model with 20 different categories in it. So I'm using this model. And what I've said is I want about 40% overlap between how the ATR looks at it. So I want to look at all the data, and I want to look at it again, an extra 40% of that. And I want to use a geofence. Remember, I generated this geofence. That's the only area that I'm interested in finding mines and tires. And I want to use this non-max suppression as well, which means it's going to automatically look at, let's say on two lines, I've seen the same target twice. It's not going to generate that target twice. It's called non-max suppression. So it's going to look at that target and its characteristics and its positional information. And it's going to say that is the same target, even though you've seen it 3 or 4 times on the same sonar survey. So it's not going to count extra targets for you. It's called non-max suppression. And I'm going to say I'm only interested in finding objects, tires, and mines which are greater than 70% probability. So I'm saying, oh, cool. Okay, let's go ahead and let's run it. So now I go to run, and it's going to start churning through this data. Now remember, this was 2 hours worth of data. Now what I'm going to do here is I'm going to set up my message log, and that's going to show me how this thing is progressing. So I'm going to just zoom back a little bit here. So here it's found some tires now. As it's finding them, it's putting them in the target catalog. So there it's found a tire. Now the minute it's found anything, I can click on, let's say, that particular tire that is, oh, this mine's more interesting. So I'm going to click on that mine. And if I hit this little button here, it'll automatically take me to that mine in the data. And I can go zoom in and see that mine in the data while the ATR is actually working. While the ATR is working, you can see how it's working through all of those data files and how quickly it's actually working. So I'm going to go look at this tire now as well. So I click on this tire, and I want to go see where that tire is. So now I can see exactly where that tire is in the data. You see the tire quite nicely. And I'm viewing that at 600 kilohertz. Let's have a look at what that tire looks like. Use the peak button, and we want to look at it. Where's the 900? High frequency. There we go. So now we can go look at it in high frequency. And each time it generates a target, it generates the target twice, in the low frequency and the high frequency. And what it does with every single target that it generates is if you go to the information button, it tells me that that target is a tire. It's automatically detected it as a tire, and it's 86.9% certain that it is a tire. And it's going through all of this data now, and it's generating all the targets. It has now finished the entire survey. It took 1 minute, 39 seconds to process 2 hours of data. It has generated 79 targets. They're all the targets that it's generated. So if you take, any of these targets here, we can look at, you can zoom in and look at the targets. This particular one is a mine. This is a Manta mine. You can look at, it says it's a mine-like contact, 99.1% probability that is that mine-like contact. So it's going through all of this data over here. See, it's found all of these mines. This particular one here, let's look at the information on that. Here it says it's a mine-like contact, 99.9% certain that it is that. Okay, so what we can do now, once we've generated this is where the human comes back into it. So what we want the human to do is to actually go through, just have a quick review of the targets. And this is interesting here, because here is an error in the sonar data. So I'm just going to zoom in a little bit. You see this area here? There's a little telemetry hit in the data. So let's go and look at that. So I go and look in, and I can see even though there's been an error in the sonar data, there's a little telemetry hit. It has still picked up the mine behind it, which is really cool. So that's pretty interesting in terms of that. So it's found all of these mines, and you can automatically go through it and look at exactly where these mines are. If you don't agree that that is a mine, let's say I don't think that this particular one is a mine, I can actually either delete that target and it's now gone, or I can hide it. So if I'm not like this thing, I'm not just sure that that is a mine, the ATR thinks it is. Let me see, it says it's 75% probability that that is a mine. And, maybe I don't believe that, so I want to just, hide that target. So I'm not really deleting it, I'm just hiding it from any, further analysis. So now in less than 2 minutes, it is processed 2 hours worth of data. Now, watch this. We want to now generate a report. So what it's done with each of these targets is it gives you 2 geotiffs. So it gives you the 600 kilohertz geotiff, and it gives you the 900 kilohertz geotiff. Oh, the other thing I didn't tell you as well is that every time it goes and finds a target, it gives you the bounding box size of that target. So you can see the width of that target. So you've got an idea of the size of it. You can sort those targets as well. So let's say that you're only interested in mines which are bigger than 1 meter. You can say only show me the targets which are bigger than 1 meter, and ignore the rest of them. So let's generate a report from this. So we go export, and we want to say generate a PDF report of that, and I'm going to call this HiPAC report. Right, and it's what do you want to include in it? You can include your projected coordinates, your motion information, file, description. I probably want. You can fill in who your project leader was. Here we've got Ralph leading the project, location, wherever it was. And so what I'm going to do is, this is a very easy way to actually generate your report. So, oops, I haven't given it a name. So we're going to call this, and I'm going to put that into my exports, and I'm going to call it the Ralph survey. Okay. So now it is generated. I'll go and find that report. There's the Ralph survey report. Oops, where is it now? Let me go and open it again. Hasn't generated it yet. Still waiting. Is it? Oh, I haven't said okay then. That's why. Helps to say okay. Right, there you go. So there is the report. Tells you, what version of the software I was using, the date that I was the author, etc. So it's gone through and it is generated the report with all of the target information, classification, found all the mines and all the tires in that data set. And the other thing is that, show you this. Do you remember the, where's the audit trail now? So source data, audit trail. Okay, so there we go. So look, here, do you remember my little color here was, let me go down to my color. I was the green color when reviewing those files. So I only basically reviewed 1, 2, 3, 4, 5, and did a very poor job of it. There was 4.2 gigs of data there. This is the ATR. The ATR looked at all of that. All of those files there, except the ones that I excluded, remember in my fence? So the ones that I excluded there. So it hasn't looked at those. So I did a poor job of looking at that data, but the ATR did a thorough job of looking at it. And again, if I had to sit and digitize 97 mine-like objects, it would take me a fair amount of time, and I'm good at this. I could not do that in 1 minute 39. But where the operator comes in is to go through all of the targets and review them. Either delete them, hide them, reclassify them if necessary before you generate your report. And each of these, in our export, I said to you, we're generating 2 geotiff images, one for the low frequency, one for the high frequency. And then we generate something called a JSON file, which is like a metadata file for each of those targets, which tells you what the probability is of each of those targets being that particular classification and everything else. So we're busy working with HiPAC at the moment. So HiPAC will be able to import all of that into their target editor as well if they want to. But literally, it's so easy to import it. The JSON file is a text file. you could import that into AutoCAD with all the imagery or into ArcGIS or HiPAC or anything. It's really simple. So that is our spectral AR software. And just to finish off, I think that there's one or two more slides. Yeah, which is, let me just show you those. So basically, it only works with, unfortunately, client data. So if you've got an edge tech, tough luck. So it uses any historical data you have, and it's frequency independent. So if you have an old 3000 and you've got data, that's fine. We can work with that. Anything that client has recorded. We've also found that it's because we use raw data, it's frequency independent. So let's say Michiel and I have been out, or Bob and I have been out, and we've collected data with a 5900, which is our flagship system, dynamically focused 600 kilohertz, and we've generated our model on that. But then we've gone out and we've used, let's say, a MaxView, which is the one that we have on display at the moment. We can use that same model, even though it's built on a different sonar, because it's based on raw data. It's frequency, essentially frequency and sonar independent, so it doesn't really care. So basically, this moves you from a manual workflow into an automated workflow, which is going to save you a heap of time. And let's say that you're in this situation here, where you've got a fleet of autonomous vehicles which are collecting data. They cannot transfer all of that raw data up to the surface. It's physically impossible. The data is far too big. Side scan data is a gig an hour, and that's with one of our smaller systems. Our bigger systems, is Michiel here at the moment? Oh. How many, with the 5900, how much do we collect an hour if we're collecting raw data? A minute, okay. Again, you could never bring that up to the surface. But if you have one of those small little NVIDIA Orin computers, which runs on Linux, and our software runs on Linux as well, and you have that on the vehicle, it generates the GeoTIFF image of the target, and it generates the JSON file, and these are literally a couple of kilobytes or a couple of megs. That can be sent via acoustic modem up to a USV on the surface or back to the support vessel. So you're able, and if you had an unmanned surface vessel operating and you couldn't get the data back, you can still get targets of interest broadcast back to you on a cell network, because the data is tiny. It really is small. So this sort of is a game changer for unmanned or uncrewed operations. Any questions, ladies and gentlemen?
I want to change my project name from BS to ungodly.
That's only with SDFs, right? Not XDFs.
And any SDF, going back to the Client 3000, works perfectly. Yeah. So that's where, don't be scared of artificial intelligence in this instance. It's very constrained. It's not going to get into your bank account. It can only do, unless your bank account has SDF files in it, then it's fair game. But yeah, it only works with SDF data. And it's, as you've seen, there's something that what I did there was pretty hard. I mean, finding mines is a hard task. It's not easy, and that system works. As you see, live demo worked well. So. Yeah, so if you guys want to talk about it a little bit more, you can see Bob or Michiel or myself at stand 22. Thanks for your attention.